Hello students, I am Mrs. Anjali Nadagouda, lecturer in chemistry, KLS Gokte PU College, Science Section, Belagavi. We are continuing with the topic electrochemistry. This is video number 5. We have in my first video of this topic, I told you that there are two types of cells. One is electrochemical cell and second one is electrolytic cell. Up till now, we have studied about the electrochemical cell in detail. Today, we will learn electrolytic cells and electrolysis. So, what is electrolytic cell? The cells in which electrical energy causes the chemical reaction. This is called as electrolysis. Chemical reaction is called as electrolysis and the cell is called as electrolytic cell. So example is copper coulometer. In textbook, page number 83, the details are given. In an electrolytic cell, external source or voltage is used to bring about a chemical reaction. Whenever suitable reducing agent is not available for the reduction of metal, then the electrolysis is carried out. That is, external voltage or source is applied to bring out the reaction. Now, why this is carried out? So, this type of cell, that is electrolytic cell, is used to get the metal of high purity. That is, for purification of metal, this method is used. In textbook, the example is given of copper, how the copper is purified by using the impure copper rods. So, when the electrolysis is carried out, the external voltage is applied and one rod is made up of both the electrodes are made up of copper, that is impure copper, and one is attached to cathode and one is attached to anode, and this is how the electrolysis is carried out. So in that method we will get the pure copper. Okay. So, the electrochemical process are of great importance in the laboratory and in the chemical industry. How this is done? Many metals like sodium, magnesium, aluminium, etc. are produced on large scale by electrochemical reduction of their respective cations where no suitable chemical reducing agents are available for this purpose. What is electrolysis? We have already learnt, that is the decomposition of the electrolyte into its own ions by applying the external voltage. So this process is called as electrolysis. Now let us see the definition. The process of decomposition. Decomposition means breaking of an electrolyte by passing electricity through it is called as electrolysis. Michael Faraday was the first scientist who described the quantitative aspects of electrolysis. Now, what is meant by quantitative aspects? He has shown, that is, how much amount of substance is liberated at any electrode when the quantity of electricity which we are passing through it is known. So this is given by the laws. So let us start with Faraday's first law of electrolysis. It states that the amount of substance deposited or liberated at any electrode during electrolysis is directly proportional to the quantity of electricity passed through the electrolyte. It may be in the form of solution or it may be in the form of melt. So amount of substance deposited or liberated. Let us think it is W. At any electrode during the electrolysis, means by applying the external voltage, is directly proportional to the quantity of electricity. So quantity of electricity is considered as Q. So this is mathematically it can be expressed as W is directly proportional to Q, where W is mass of the substance deposited or liberated. Q is the quantity of electricity passed in terms of coulombs, because it's a charge. But as we know, Q is equal to I into T, that is I is current in ampere and T is time in second. So W is directly proportional to I into T. Now to remove the proportionality sign, we must take the constant. So this constant is taken as Z. So where Z is electrochemical equivalent, that is ECE of that material for which the electrolysis is carried out. Okay. Now this question can be asked for 2 marks, that is write the statement of Faraday's first law of electrolysis and write its mathematical expression. What is Z is then? It's a proportionality constant. So how it can be defined? It is the mass of substance deposited when 1 ampere of current is passed through an electrolyte for 1 second. Or we can write, that is the amount of electricity or charge required for oxidation or reduction depends on the stoichiometry of the electrode reaction. So charge on one electron is equal to 1.6021 into 10 to the power minus 19 coulomb. This we have learnt in last year. 1 mole is nothing but how much? 6.022 into 10 to the power 23 per mole. So charge on 1 mole of electrons is 6.022 into 10 to the power 23 into 1.6021 into 10 to the power minus 90. That is nothing but 96,487 coulomb per mole, which is approximately taken as 96,500 coulomb per mole. Now what is this value? This is the value of charge of 1 mole of electrons. 1 mole of electrons, remember. So this quantity of electricity is called as Faraday and is represented by symbol capital F. Now the second law. What is Faraday's second law? It states that the amount of different substances liberated or deposited by the same quantity of electricity passing through the electrolytic solution are proportional to their chemical equivalent weights. Now here the same amount of electricity is passed through different electrolytes. Same amount of electricity or same quantity of electricity is passed through different electrolytic solutions. Then in that case, the amount of different substances liberated or deposited are proportional to their chemical equivalent weights. So how these equivalent weights are calculated then? That is atomic mass of the metal divided by number of electrons required to reduce the cation, means to convert it into cation. Suppose Na gives Na plus by losing 1 electron. So here atomic mass of the metal of sodium is 23 divided by number of electrons required is 1. So what is the equivalent weight? 23. So this is how they are proportional to their equivalent chemical equivalent weights. Or one more statement is given. It states that when same amount of electricity is passed through different electrolytic solutions, the masses of the substances deposited or liberated at the electrodes is directly proportional to their equivalent masses. Now, these two statements can be asked for the exam for 2 marks with their mathematical expression. What is the use of Faraday then? Why this charge on 1 mole of electrons is asked? Because based on this we can solve some problems. Now, how the product of electrolysis can be given? Factors that determine the products on electrolysis. So what are the factors? Nature of electrolyte, type of electrode used, then standard electrode potential of competing ions, means which ions are forming in that and what is their standard electrode potential. Next one is concentration of electrolyte solution, and fifth one is over voltage or over potential. That what is over potential is the minimum excess potential over the standard electrode potential required to discharge an ion is called as over potential. So by knowing all these factors, anyone can carry out the electrolysis to get the pure metal, and this method is applied industrially, especially for the purification of aluminium or copper, or even for sodium, etc. Now let us take example. Electrolysis of molten NaCl. Now what is meant by molten NaCl is solid NaCl, when it is heated it goes in liquid form, and that form is called as molten or fused NaCl. So when such electrolyte is used, now this acts as electrolyte. So when such electrolyte is used for the electrolysis, means in this solution, in this molten NaCl, if the two rods are dipped, one is attached to cathode and another one is attached to anode, then at cathode we will get molten sodium metal, at anode we will get chlorine gas, because NaCl decomposes as Na plus and Cl minus. So as Cl is minus, it goes to anode, and Na is plus charge, it goes to cathode, but it is in the form of molten Na, that is in liquid form. Instead of that, if electrolysis of aqueous NaCl is done, that is brine, we call that solution it as brine. So what is aqueous NaCl? Aqua means water, means NaCl when it is dissolved in water. Saturated solution is used. Now what is meant by saturated? That is quantity of solute, that is sodium chloride, is more compared to the quantity of solvent. So in this case, again the same electrolysis method is applied. Then at cathode hydrogen gas is evolved, whereas at anode chlorine gas is evolved. Now why this happens, that we will learn in next slide. So electrolysis of aqueous NaCl. During electrolysis of aqueous NaCl solution, the products are NaOH, Cl2 and H2. Now here you may get surprise, we are taking aqueous NaCl solution, and how we are getting the product as NaOH. See here, we are taking aqueous NaCl solution. Aqueous means which is dissolved in water, means along with NaCl, even water also ionizes as H plus and OH minus. So how many ions are produced in this? In this case, Na plus, Cl minus, also H plus and OH minus are ions are formed in the solution, right? and H plus and OH ions are from what? Solvent molecules, that is water, and Na plus and Cl minus are from NaCl. So at cathode what happens? There is a competition between the following reduction reactions. Always at cathode reduction takes place, that is gain of electron takes place. So let us see the reaction. Na plus E, that is it accepts the electron, forming Na, that is solid. Sodium solid metal is formed, and E naught cell, that is standard potential of sodium electrode, is minus 2.71 volt. Then H plus ions are formed from water, that is aqueous medium. This also accepts the electron, forming half hydrogen gas. Now why half hydrogen gas? Because here only one H ion is formed. One H ion accepts form one H. This is how two H ion combines to form H2 gas, and therefore we have written half H2. So this is in the form of gas. Now here E naught cell value is 0.0 volt. Just look to the values. One is minus 2.71 volt and one is plus, that is 0. So which one is bigger in this case, or which one is large value? 0.0 volt is larger value. So what happens? The reaction with higher value of E naught is preferred at cathode. Therefore, the reaction at cathode during electrolysis is which one? H plus accepts E and it forms half hydrogen gas, and hence at cathode hydrogen gas is liberated. This is equation number 1. But H plus, that is from aqueous, is produced by the dissociation of water. So what we have to write? H2O, that is liquid, gives H plus and OH minus. This is equation number 2. Therefore, the net reaction at cathode is sum of 1 and 2. So 1 and 2 means this H plus will get cancelled. This H plus and this H plus will get cancelled because they are on opposite side. Then remaining part is H2O liquid, then plus E on reactant side. On product side what remains? Half H2 gas and OH minus, that is hydroxyl ion. So this is the equation which takes place at cathode, and this is how which gas is liberated? The gas liberated is half H2, that is hydrogen gas is liberated. Now what happens at anode? At anode always oxidation takes place, that is loss of electron takes place. So which reactions are possible? Even at anode two reactions are possible. One is Cl minus ion, that is negatively charged ion, gives half Cl2 plus E minus. So here also the electrons are lost, and this E naught cell value is 1.36 volt. Whereas from water also oxygen gas is formed by oxidation and it loses 4 electrons, forming E naught cell value for this is 1.23 volt. These are standard values. Now out of these two reactions, which one is having lower value? Lower value is equation number 5, that is oxidation of water forming oxygen gas, right? The reaction at anode with lower value of E naught is preferred, and therefore water should get oxidized in preference to Cl minus aqueous. That is which reaction should take place? That is fifth reaction should take place. But what happens? Due to over potential of oxygen, means to form the oxygen, the required voltage is very much large. Though the voltage is given like this 1.23 volt, actual in practice it is more. More means what happens exactly? So H2O decomposes in two steps, that is one is H2O get converted into H2O2 peroxide, and this is one, and there are two water molecules we have taken. So again the oxidation takes place, forming oxygen. So this is how this reaction takes place in 2 steps. And for first step, that is for water, oxidation of water into hydrogen peroxide, it requires nearly 1.76 volt potential, and hence practically this is not possible. That we call it as what? Over potential of oxygen, and hence reaction 4 is preferred, that is formation of chlorine gas. And hence therefore at cathode hydrogen gas is liberated and at anode chlorine gas is liberated. So whatever factors now we have studied, just see the factors again once again. Nature of electrolyte, that is whether it is in molten form or whether it is in aqueous form, depending on that product changes. Then types of electrode used, which electrodes are used, maybe the same metal rod or maybe the carbon or any other electrodes are used, again the product changes. Standard electrode potential of competing ion. So we have already, now we have seen the example. If there are two ions are competing for the at the same electrode, then which one goes earlier to that electrode? Then concentration of electrolyte solution, how much you are taking the concentration, whether it is more concentrated or whether it is dilute, depending on that also the product of electrolysis changes. Then over potential, that is over voltage. So this also we have seen now at anode in electrolysis of sodium chloride. So this is how the electrolysis this is how the electrolysis is carried out, and we will get the different products. Now let us see the next net reaction. So the net reaction may be summarized as NaCl aqueous, that is in water, Na plus and Cl minus. These ions are also in aqueous form, remember. At cathode what happens? H2O plus E gives half H2 plus OH minus, that is hydrogen gas is liberated, and at anode Cl minus gives half Cl2 plus E, that is loss of electrons. So which gas is formed here? Chlorine gas is formed. So net reaction is NaCl plus H2O gives Na plus. Now remaining ions, which ions are remaining now? One is OH at cathode, OH minus, and Na plus. So both they are combining to form NaOH, and this is how the total products of electrolysis of NaCl, that is aqueous NaCl, are NaOH, that is sodium hydroxide, then hydrogen, and then chlorine. Now what may be the questions asked on this part is, which gas is liberated at cathode or at anode during electrolysis of aqueous sodium chloride? Then which method is applied, or by which method we can get the caustic soda very easily? One is, that is saturated electrolysis of saturated NaCl solution, that is brine. So this is the industrial method for preparation of NaOH, that is caustic soda. So in today's class what we have learned, what is electrolytic cell, then what is electrolysis, what is its industrial application, and Faraday's law. So in next class we will solve some problems based on Faraday's law. So the question on Faraday's law is asked in 1 mark question, that is in the form of problems. And in these problems the number of electrons, transfer of number of electrons is important. Thank you.